Hi guys, and welcome to your section 3.2, that's chapter 3, lesson 2, notes on solving inequalities with addition or subtraction. So basically just addition, remember, because subtraction is just backwards addition. So remember in chapter 2 when we were solving equations, we would use properties of equality to solve equations, but this time we're going to use properties of inequality to solve inequalities. They're basically the same thing. It's going to be great. Just like we had equivalent equations, this time we are going to create equivalent, you ready for this? Equivalent inequalities. And that seems like kind of an oxymoron, right? How can you have an inequality that, because inequality that's like not equal, but how can you have an inequality that is in fact equal? Well, they're equal because they have the same solution. Example, if you had like x is greater than 4, that's equivalent to x plus 4 is greater than 8, because you just add 4 to both sides and you get x plus 4, and 4 plus 4 is 8. Isn't that great? So great because rhymes with 8. Right? So let's talk about some properties. The addition property of inequality says that if you have A is greater than B, then A plus C is greater than B plus C. So you still have your A and your B, but you just add plus C to both sides, it's still greater than. If A, and this adding C to everybody, it works no matter what you do, no matter what your sign is, it's going to be the same all the way down. So if you have A is less than B, then A plus C is still less than B plus C. If you have A is greater than or equal to B, then A plus C is greater than or equal to B plus C. And finally, if you have A is less than or equal to B, then guess what? A plus C is less than or equal to B plus C. So let's look at a couple examples real quick. If we have something like 5 is greater than 4, and then we add 3 to both sides, well, 8 is still greater than 7. That still works. Or if you had like 3, let's do negative 3, is less than or equal to negative 1, it's true, and you subtract 10 from both sides, well, guess what? Negative 13 is less than or equal to negative 11. So that still holds true. Remember to listen for a key word today in our lesson to make sure you're paying attention. Today's key word is pupusa. Pupusa is a kind of Central American food that's really good, and I recommend you eat them. So first, what are some solutions of x minus 5 is greater than x minus 12? Well, if we're solving for x, we want to undo what's happening to our x. What's happening to our x? Well, they're subtracting 5. So to undo that subtract 5, we'll add 5 to both sides. That gives us x is greater than, negative 12 plus 5 is negative 7. So there's our solution, x is greater than negative 7. Remembering that our secret word of the day is pupusa. But how do we graph this? We need to graph it on a number line, remember. So we draw a number line and we'll feature negative 7. And then you want to add some numbers around it. It's got negative 6, negative 5. And then going, ooh, that's not even. And then going down, negative 8, negative 9. And because we have strictly greater than, that'll give us an open circle at negative 7. And then any number greater than negative 7 puts us going to the right because we're feeling all right. Now let's check. Let's check our solutions. We said that negative 6 is a solution. Is it true that negative 6 minus 5 is greater than negative 12? Remember, subbing in negative 6 for x. Well, negative 6 minus 5 is negative 11. And yes, negative 11 is greater than negative 12. Fantastic. What about if you have 10 is greater than or equal to x minus 3? Again, we're trying to get our x on one side of an inequality. So to undo what's happening to our x, we're going to add 3 to both sides. This gives us that 13 is greater than or equal to x. So any number that's 13 or bigger is going to satisfy this. So let's graph our solution. We'll start out with 13. We have 14 over 15, and going even farther the opposite way is 11 and 12. And this is greater than or equal to. So that'll give us a closed circle at 13. And 13 is greater than or equal to x. So let's try a number. If we had x is 14, is 13 greater than or equal to 14? No. So I think I misspoke earlier. We actually need to go this way. And let's check. Let's check 12. Why not? Is it true that if we plug in 12 for x, we have 13 is greater than or equal to 12? Oh, wait, that's the wrong thing. We plugged it into the wrong thing. Good job, me. Is it true? What are we testing? 12. That 10 is greater than or equal to 12 minus, I did the next step in my head already. 12 minus 3, we're plugging in 12 for x. Well, 10 greater than or equal to 12 minus 3 is 9. Is 10 greater than or equal to 9? Yes, indeed. So any number 13 or smaller will work here. Okay, so that's using addition. Now, the same rule applies for subtraction. And guess what, guys? Because in the spirit of notability, I'm going to copy and paste to save us some time. Here we go. Okay, so the subtraction property of inequality states that if you have a, b, and c, and if a is greater than b, then a minus c is greater than b minus c. Basically, subtracting the same number from both sides is not going to change your inequality, whether it's greater than, less than, greater than or equal to, or less than or equal to. And why does this work? Well, it works because let's say you have, negative 3 is less than 5. That's true. I don't think anyone will argue with me on that one. If we subtract 2 from both sides, we get negative 5 is less than 3. That is still true. Yay, so subtracting the same number from both sides of an inequality doesn't change anything. Well, what if it's greater than or equal to? Because 10 is greater than or equal to 9. Now, if we subtract 1 from both sides? Well, 9 is still greater than or equal to 8. So subtracting the same number doesn't change anything. We're going to use this tool. We're going to use this tool to help us make equivalent, simpler inequalities. So here we want to get t all by itself. So to isolate t, let's undo what's happening by subtracting 6 from both sides. That'll give us t is greater than negative 10. And let's check our solution. And by check, I mean graph. We can also check it. So we have negative 10 here. To add some numbers greater, we've got negative 9, negative 8, 11, negative 12, negative 13. Okay, so we have t is greater than negative 10. This gives us an, wrong tool. This gives us an open circle. And we're going to highlight all the numbers greater than 10. By the way, if you don't have like a color coding thing and you want to make your number line, like highlightingness, go above the line, that's also totally fine. You can get away with that. So let's check to make sure our graph is going the same way. Let's use negative 8. If we plug in negative 8 in for t, we have negative 8 plus 6 is greater than negative 4. Well, is that true? Negative 8 plus 6 is negative 2. Negative 2 is greater than 4? I mean, negative 4? It's definitely not greater than 4. But negative 2 is in fact greater than negative 4. Super duper. We did it. Okay, that's great and all, but when are we going to use this in real life? Well, let's say you've got a hard drive on your computer with a maximum capacity of 120 gigabytes. You've already used 85 gigabytes. You want to save some home videos on your computer. So what are some possible sizes of videos that you can save? Well, I'm going to draw a diagram to help me plan this out. So I know that in total, because we're dealing with memory, I'm going to draw one of those like memory banks and I'm going to make it the same size. Nice. Okay. So I have a capacity of 120 gigabytes. So I can use 120 gigabytes in total. And I have already used 85 gigabytes. And this is not going to be to scale, but like there. 85 gigabytes is already taken. By the way, if you want to check out what this really represents right now, you can go into your iPad storage, go to your settings and find storage or like memory storage. They do this all the time. And however much we have needs to be up to 120 gigabytes. So this needs to be less than or equal to 120 gigs. So we've got 85 already used. And then we have remaining for videos. Let's make it green. So how much memory is remaining? What are possible sizes of videos? How much memory is remaining? Oh, and 120 is blue. Is our total memory remaining. Okay, great. So let's put this into algebra. So we've got 85 plus, how about m for memory? 85 plus m is less than or equal to 120. Now we need to find out what is m. So we're going to subtract 85 from both sides. This gives us that m is less than or equal to 35. So we can use up to 35 gigabytes of videos. And depending on the lengths of your videos, that's a pretty fair amount. It's not a whole lot, but it's respectable. So there you go. Yep. So just basically you guys treat an inequality like an equation to find a solution, and then have a fantastic time on your homework.